Hello everyone, myself Shahid-ul Islam, instructor for today NEET Physics Digital Solution powered by Platform. Welcome again to sample NEET mock paper on new pattern of test taken from NEET test series conducted by Premier Institute Platform. As you already know, the test pattern of NEET UG comprises of two separate sections. Section A will consist of 35 MCQs and Section B will have 15 MCQs. Both sections of Physics, Chemistry, Botany and Zoology are based on the single option correct. As per our prediction, Section A will have MCQs completely on reduced syllabi. And the paper will having optional questions and students are not expected to attempt more than 10 questions in section B. My dear students, one of the biggest challenges are procrastinations and space and time management. To manage time, everyday periodic practice is very important. You need to stay consistent in your preparation. It takes time, but trust me, it will be worth it at the end. If you really want it, then you have to work for it. Nothing comes easy. If something was relatively easy to get, everyone would have that right. Don't forget that 3 hours paper with 180 questions is going to charge your entire 1 or 2 years of preparation and define your rest of entire life. Do your best and be like stem cell. Differentiate yourself from others. The harder you will work for something, the greater you will feel when you achieve it. My request to all students and the viewers to stay tuned with us. Watch this video at free time without wasting your study hours. Try to solve the problem first pausing video and check the digital solution with what you have done. Please do subscribe and share the link to your friends. Subsequent digital solution on new pattern of test for NEET 2021 will be uploaded. And the first questions here, we'll be dealing here with the section A, which having 35 MCQs, you know. Question number 1, a jeep runs around a curve of radius 0.3 km at constant speed of 60 meter per second. The jeep covers a curve of 60° R. Here 4 options given. Resultant change in velocity of jeep is 60 meter per second. Instantaneous acceleration of the jeep is 12 meter per second square. Average acceleration of jeep is approximately 11.5 meter per second square, and the fourth option all are correct. So there is no specific question is asked in this problem. So let us check all the option here. So before that, you know, particle moving in a circular path at constant speed. Let us say the velocity at the point is v1 and the velocity at this point is v2, makes an angle 60° by the line joining with the particle and center. So the distance S is equal to, you know, r theta. Here r is equal to 300 meter and this is pi by 3. And simply this is 100 pi meter, and time taken del t is equal to s by v. S is equal to 100 pi and v in this problem given 60 meter per second. This is 5 by 3 pi second. This is the time taken by the particle. Option 1, you know, we have to find out the change in velocity. Change in velocity change in velocity del v square equal to, we can write v1 square v2 square minus 2 v1 v2 cos theta. Since the speed is uniform, we can write magnitude of velocity v1 and magnitude of velocity v2 equal to u. The magnitude of the velocity at each and every point of the circle is constant, but direction changes continuously, so velocity changes continuously in this circular path, but the speed of this particle is constant. Here we can write u square plus u square, this is 2u square cos theta, and finally this is 2u square 1 minus cos theta, 2u square 2 sin square theta by 2. So the change in velocity, it is 2v sin theta by 2. And this is 2 into 60 meter per second, and sin theta value is half. Value of sin 30 degree, that is 60 by 2 is equal to 30 degrees. So this is 60 meter per second. So option 1 is also the right statement of this problem. It is the right statement. It is true. Next option, instantaneous acceleration of the jeep. Instantaneous acceleration of the jeep, I mean it is actually centripetal acceleration. Centripetal acceleration AC equal to, we can write u square by r, and it is 60 into 60 by 300, and this become 12 meter per second square. Okay, so option 2 is also the correct statement. Average acceleration of the jeep approximately. In the case of average acceleration, instantaneous acceleration at any point of the particle moving in a circular path, but option 3, we have to find out the average acceleration. In the definitions of average acceleration, we can write a average, that is change in velocity by change in time. Here we have already find out 60 is the change in velocity, and time taken to cover the path, the specific path from one point to other point, making an angle 60 degree at the center by the line joining between center and particle. And the time taken, this is 5 by 3 into 5, so 36 by 5, and calculations 36 by 5, roughly it is 11.5 meter per second square. So option 3 is also true, but 1, 2, 3 are not the correct option, because 4th option are given here, all are correct. So we have to check all the option here 1, 2, 3, but 1, 2, 3 all the option given 1, 2, 3 are the right option, correct statement of this problem, but 1, 2, 3 are not the correct option here, because the fourth option given all are correct. So we have to choose the option 4. Okay, move on to the next problem of this video session. The speed of boat is given 18 km per hour in still water it crosses a river of with 2 km along the shortest part in 7 minutes. The velocity of the river is, so this is the case based on the time taken to cross the river in shortest path. Starting point is A and finishing point is B. So if one has to cross the river through the minimum path, the boat or the swimmer has to lean with an angle theta against the direction of river. Okay, so V is the velocity. Let us say V is the velocity of the boat and U is the velocity of the river. So boat has to lean with some particular angle theta with the vertical, that is with the breadth of the river, against the direction of river, against the direction of current. So here V sine theta, if it is equal to U, then V sine theta and U cancels out each other, and anyone can cross the river along the shortest path, and it can reach the finishing point B. And along this direction, the velocity of the boat is V cos theta. And so time taken to cross the river, we can say T is equal to, if the breadth of the river, let us say it is B, then we can say the B by U cos theta, and this is B U root over of V square minus U square by U. So this is B by root over V square minus U square. So you need to remember this formula, that is T is the time taken by the boat to cross the river, V square minus U square root over, and this is the time taken by the boat to cross the river through the shortest path or through the minimum path. Okay, and let us calculate this problem. Here in this problem, time taken, it is T B by root over V square minus U square, and the time given in this problem is 7 minutes. This is 7 by 60, and the breadth of the river given is equal to 2 km. Root over of V square, that is the speed of boat, is 18 km. It is 18 square minus U square. Okay. And root over of 18 square minus U square equal to 120 by 7, roughly it is 17.1, and it is 18 square minus U square. So 18 square minus u square equal to 17.1 whole square. So u square we can write it is 18 square minus 17.1 whole square. And 18 square, it is 324, 18 into 18 and 17 into 17 is equal to 2, roughly it is 292, and the difference is 32. Let us check the option given in this problem 1, 2, 3, 4. First option given here 5.5, that is we can write u is equal to 5.5 kilometer per hour, and the right option matches with 1. Moving on to the next problem. A ball is thrown from the top of a tower with an initial velocity of 10 meter per second at an angle 30 degree with the horizontal. If it hits the ground at a distance of 17.3 meter from the base of the tower, the height of the, we have to find out here the height of the tower. Let us say a ball is thrown at an angle 30 degree with the horizontal, and you know it has the two component. One component is u sine 30 and horizontal component is u cos 30. Because of the horizontal velocity, particle displaces horizontally, and this distance is given in this problem is equal to 17.3 meter. If the time taken by the particle to fall the ground, if it is t, then we can say u cos theta into t equal to 17.3 meter. So particle displaces horizontally because of the horizontal component of the velocity. And here u cos theta, u given in the problem, this is 10 meter per second, and angle given cos 30. Cos 30 is equal to root 3 by 2, and t, this is 17.3, and t is equal to, we can write 34.6 by 17.3, and this value becomes 2 seconds. So time taken to fall on the ground or strike the ground, it is 2 seconds. And you know, initial positions of the particle, this is the initial position, and particle finally strikes the ground at the point, let us say it is B. The particle displacement in this problem is equal to h, and this is initial position. With respect to the initial positions, if we take the direction downward as negative, with respect to the initial positions, the displacement of particle is minus h, vertical displacement. And initial vertical velocity, upward direction, if it is taken positive, if we take downward is negative with respect to initial position. So with respect to initial positions, the direction of velocity initially upward, so it is plus. So we can write it is u sine 30 into t plus half. Direction of g all time it is downward due to the gravity, and the direction of this is minus into t square. Finally, h equal to, the equation becomes half g t square minus u sine 30 into t, and putting the value, by default we can take the value of g is 10 since there is no information given in this problem. So by default we have to take here the value of g is 10, and it is 4, u is 10 meter per second, it is half into 2, and finally the answer, it is 10 meter, and the right option matches with 4. Hope that you have got it what I have discussed. First of all, you have to resolve two component. One is horizontal component, that is vertical component. Because of the vertical component, particle ascend vertically up and then it is returned to the ground because of the gravitational acceleration which is already downward, and because of the u cos theta, that is horizontal component of velocity, particle moves horizontally and it will fall at a distance from the base of the tower, and this is given as 17.3. So from this data I have found out here the time taken to fall the ground, it is 2 seconds, and in this way you have to maintain the direction of the, in this case since the particle has the velocity upward initially and displacement, it is finally it is downward, finally it is initial portion, this is final portion, so displacement is h, vertical displacement is h, but with respect to the initial point, the vertical displacement we have to take here minus, and upward direction we have to take here plus. Maintaining this convention, finally we get the equation of the height of the tower is equal to half g t square minus u sine 30t, and putting the values given, value of time, so the height of the tower becomes 10 meter. Okay, moving on, let us see the next problem. The length and breadth of a rectangular sheet are 16.2 centimeter and 10.1 centimeter. So area, in this problem we can say the area equal to length into breadth, you know, length in this problem it is equal to 16.2, and the breadth of this problem, breadth of the rectangular sheet given in this problem is 10.1, and by calculation we can get 16 into 10, roughly it is 160, so it is 160, more than 162, the value of this more than 162. I think it is just by going through the option 1, 2, 3, 4, I think the value it is 163.62 centimeters square. But you know, we have to write the approximate significant figures. In the case of multiplication, I must say here, in the case of addition, subtraction, and you know, multiplication and division, in the case of multiplication we have to check the least number of significant digits, in the figure of multiplication, or in the case of addition and subtraction we have to check the significance digits after the decimal, number of significant digits after the decimal. I am repeating, in the case of multiplication and division we have to in the result the least number of significant digits written. Here the least number of significant digits in the figure, it is 3, so least number is 3. So result should be written or should be reported in form of least number of significant digit in the case of multiplication. But by approximation, it is actually 3 significant, in the result must be reported in 3 significant digits. But here significant digits is 5, but we have to write the result in 3 significant digits. It is actually 163, but no such option given 1, 2, 3. That is significant digits in the case of area, significant digits in the case of area, it is 5. So 2, 3, 4 are not the correct option here. So result must be reported in 3 significant digits. But 163.62, if it is approximated, then it can be written as 164 centimeter square. So only checking the area of this rectangular sheet, we can find the answer, because you know the result must be reported in appropriate significant figures. So we need not to calculate the error for this problem, particularly in the examination hall. Let us move the next problem. Question number 5. It is known that the time of revolution T satellite around the Earth depends on the universal gravitational constant G and the mass of Earth is m. The radius of the circular orbit is r. Obtain an expression for T using the dimensional analysis. The question based on the dimensional analysis. But before going to analysis the dimensional analysis, here option 1, 2, 3, 4, all 4 options are dimensionally different quantities. First you know r to the power q by gm, and it is r to the power 5 by gm, r by gm, and gm by rq. So all 4 options are different dimensional quantities. Here my suggestion, you don't go to solve this problem by dimensional analysis. My suggestion, you know, the dimension should be equal to the time period. This is T, and you know GM, dimension of GM, it is equal to, we can write it is GR square, and G equal to, it is L T to the power minus 2 into L square, and finally it is L Q T to the power minus 2. So if we put the dimension of GM in the equation, so in the first option it is root over of RQ by GM. So by checking the dimension of the time, it is RQ is equal to, you know, LQ by LQ T to the power minus 2, and this becomes T square. So the dimension is T. So dimension of the RQ by GM is equal to the dimension of time. So right option here is 1. Next problem. A car of mass 1000 kg negotiates a bank of curve of radius 90 meter on frictionless road. If the banking angle is 45 degree, the speed of the car. So normally any bank road having some friction, but in this problem basically specially mentioned in frictionless road, though it is not possible practically, every bank road has some friction. Since this problem specially mentioned frictionless road, so the problem based on the velocity, we have to find out the velocity up to which, that is, maximum velocity up to which car can travel without turning over. And this is actually tan theta. Theta is the bunking angle of the inclined path. Tan theta is equal to, we can write v square by rg. And so v square equal to, we can write rg tan theta are given in the problem 90 meter. It is 90 into 10 into tan 45, 900. So the maximum velocity, it is 330 meter per second. Let us see the next problem of this video session. The ratio of the angular speed of second hand to the hour hand of a watch is. Second hand, angular speed of second hand, angular speed of second hand, let us say omega 1 2 pi by 60 rad per second, and the angular speed of our hand omega 2 equal to twice pi by 12 into 60 into 60. It is also rad per second. We have to find out the ratio omega 1 by omega 2. So this is 12 into 60 into 60 by 60, and it is 720. Okay, so right option here is 2. Simple problem. Next, a uranium-238 nucleus decays by emitting alpha particle of speed v meter per second. The recoil speed of the residual nucleus in. So by emission of alpha particle, molar mass of residual nucleus, it is 238 it is given, and due to the emission of alpha particle, mass number decreases by 4, so it is -4, and this is 234. And from the conservation of momentum, it is the nucleus of 238. If one alpha particle is emitted, let us say it is alpha particle, so the mass number of this nucleus becomes 234, and the velocity, recoil velocity, let us say v. We can say the momentum of the nucleus and the velocity of nucleus is equal to mass of alpha particle into velocity of alpha particle from the conservation of momentum. So the velocity of residual nucleus, it is equal to m alpha by m nucleus by u, and this is mass of the alpha particle, it is 4, and the mass of the nucleus of the residual nucleus is equal to 234 into u. Since the direction of the velocity of alpha particle and direction of the residual nucleus is opposite to each other, because you know before explosion the momentum of this particle is 0, and after explosion the momentum of the particle it is mv vector plus m alpha u vector. This is the total momentum after explosion, and this momentum from the conservation we can write mnv vector plus m alpha u vector equal to momentum before, and this is actually 0. So from the conservation of momentum we can write here the direction of momentum of the nucleus and the direction of the velocity or momentum of the alpha particle are opposite to each other. So here the right option here it is minus, so option 1 is the correct option. Next problem. A ball is allowed to fall from height of 20 meters if there is 50% loss of energy due to the impact. After one impact, ball will go up to, let us say ball will go up to, let us say the ball will go up to mgh prime. So let us say the ball will go up to the height h prime after impact, and because of that the potential energy of the ball becomes mgh prime, and before striking, when the ball is dropped from a, let us say from the height h, and the potential energy of the ball was mgh, so 50% of the potential energy, that is 50% of the energy loss. So potential energy, gravitational potential energy of the ball is half of the potential energy of the previous situation. So simple, it is h prime is equal to h by 2. So simple problem here, 20 by 10, it is 10 meter. Very much simple problem asked here. So answer, right option here is 4. Next problem. Question number 10. A uniform rod AB of length L and mass M is free to rotate about the point A. We have to find out here the initial angular acceleration. Here the rod is rotating about a point. A. It is placed initially in a horizontal positions. You know the weight of the rod. Total weight of the rod supposed to be concentrated at the center of mass of the rod, and because of the weight, due to the weight of the rod, it will produce the moment of force about the point A. A point is the point of rotation. So torque about, better to say it is moment of force. Moment of force about A, it is tau equal to mg into L by 2. L by 2 is the perpendicular distance between the point of rotation and the line of action, and due to this it will produce angular acceleration, that is initial angular acceleration of the rod, it is I alpha equal to, we can write mgl by 2, and the moment of inertia of the rod about it one end, it is 1/3 ml square into alpha, and this is mgl by 2. So alpha, the value of alpha equal to 3/2 g by l. Correct option matches with 1. Moving on to next problem. Question number 11 says the total kinetic energy of a body of mass 10 kg and radius 2 meter moving with the velocity 10 meter per second without slipping. That is the body rolling over the horizontal surface. It is the rolling of the body over surface. The velocity of center of mass, let us say it is v. Then the total kinetic energy of the body half mv square 1 plus k square by r square. It is the total energy. So this problem is also based on the rotational mechanics and particularly for the rolling body. And in this problem, half mv square 1 plus k square by r square, it is given 750 joule, and half the mass of the body given 10 kg and the velocity of the body is 100, that is velocity square 100, and it is 1 plus k square by r square, it is equal to 750. So simply by calculation we can write 1 plus k square by r square equal to 750 by 500, and finally 1 plus k square by r square equal to 3/2, and k square by r square equal to half, and k square is equal to, we can write here r square by 2. K square equal to r square by 2, and it is 4/2, and the value of k square is equal to 2. So radius of gyration of the rolling body, that is k, it is √2, it is 1.4 meter. The correct option matches with 4. Next problem of this session. A bar magnet is held perpendicular to uniform magnetic field. It is the couple acting on the magnet is to be halved by rotating it. Then the angle by which it is to be rotated is. In a magnetic field, is magnetic needle is placed at an angle 90 degree. A magnetic needle is placed at a magnetic field perpendicularly, so the torque on the magnetic needle, we can say tau is equal to mb sine 90, and it is equal to mb. M is the magnetic moment. Magnetic moment of needle. If the couple acting on the magnet is to be halved by rotating it, couple is halved. I think the moment of couple is halved, that is torque. It is actually mb sine theta, and the value of the torque, restoring torque on the magnetic needle, or it is the torque externally given on the magnetic needle to place the needle in the magnetic field. It is actually half what was given in the case when the needle is perpendicular to the magnetic field. It was mb, so therefore it is mb by 2, half of the magnetic needle, half of the torque given on the magnetic needle to placed in the magnetic field. What was the previous? That is mb by 2. So therefore it is sine theta equal to half and theta equal to 30 degrees. So the questions asked is very simple and based on the magnetostatic, that is magnetism. Okay, so right option here is 4. Let us see the next problem. The soap bubble formed at the end of a tube is blown by a breeze slowly with time. Which graph is best situated in excess for the excess pressure inside the bubble with time? The soap bubble formed at the end of a tube is blown very slowly with time. It is the bubble formed at the end of a tube, and radius of the bubble, let us say it is r. We can say the excess pressure inside the bubble P is equal to 4s by r. R is the surface tension of the liquid, and here pressure proportional to 1 by r. If the radius is increasing with the time passing on, we can say the pressure of the bubble goes on decreasing, and this will be represented by the graph 1. This is not linear change, so 1 is not the right option here. P with T, pressure with the time the radius of the bubble increases, so it is also not the right interpretation of the, this is not the right interpretation of the pressure versus radius of the soap bubble. And you know the pressure P into R, here we can write pressure P into R, it is remain constant. So the nature of the graph predicted by this equation, it is hyperbolic in nature. So the option 3 is the correct option. 4 is also not the correct option. Right option here. So it is the change with the pressure with the time is linear. So 4 is also not the correct option. Next problem. Air inside a closed container is saturated with the vapor pressure is compressed to 1/2 its volume by maintaining the temperature constant. Since the temperature constant, temperature equal to constant, so we can say pressure into volume, that is product of these two will remain constant. In saturated condition, the pressure of the bubble depends on the temperature. If the temperature increases, then the pressure of the saturated vapor pressure is also increases. Since the temperature is fixed, so it will obeys the Boyle's law, that is PV equal to constant. In the pressure becomes, that is the volume of the it is compressed to 1/2 of its volume. Since the pressure and volume becomes V by 2, let us say at constant temperature, if the pressure of the saturated vapor it is becomes half, then the pressure of the saturated vapor pressure becomes 2P, that is the pressure of the vapor pressure of the previous situation, that is when the pressure is P and volume of the container is V equal to constant. So here the right option here is 1. Next problem. A gas is compressed at a constant pressure of 50 Newton per meter square from the volume of 10 meter cube to volume of 4 meter cube. Energy of 100 joule added to the gas by heating. So its internal energy. So the problem is based on the first law of thermodynamics. We know from the first law of thermodynamics, we can write del Q is the heat supplied to the gas that will change the internal energy of the gas, and some work will be done by the gas or on the gas. Here energy of 100 joule is supplied to the gas. This is del U. Work done, you know, P del V, and this is del U. Pressure 50 Newton per meter square, it is equal to 50, and the volume change from 10 meter cube to 4 meter cube. So finally the volume of the gas is 4 meter cube. Initially the volume of the gas is 10, and it is del U plus minus 300, and the change in internal energy equal to 100 plus 300, and the total internal energy change is 400 joule. Since it is plus, so answer is increase by 400 joule. 2, 3, 4 are not the correct option here. Next problem, question number 18. A particle executes simple harmonic motion along a straight line 4 cm long. When displacement is 1 cm, its velocity and acceleration are numerically equal. You know, velocity of the particle executing SHM, velocity of a particle executing SHM V equal to omega root over of a square minus x square, and acceleration we can write F equal to omega square into x. simple questions. These two velocity, the value of acceleration and the value of velocity of the particle numerically equal, and it can be written as omega square x as per the problem. It is omega root over of x square minus x square. We can write omega equal to root over of a square minus x square by x. Particle executing SHM along straight line 4 cm long. If the path length of the motion is 4 cm long, the total length is 4 cm. Then we can say the amplitude of the oscillation is 2 centimeter. Total path length is 4 centimeter. So amplitude of the simple, it is amplitude. Amplitude means the half of the total path, and it is root over of 2 square minus 1 square by 1, and the value of omega equal to 3, root 3. Sorry, the value of omega is equal to root 3. We have to find out here the time period of the particle oscillation. This is t equal to twice pi by omega. This can be written as 2 pi root over 3 second, and the right option here is 2. Next problem. Potential energy of a particle executing simple harmonic motion. It is again asked on the problem, asked on the simple harmonic motion. Energy given when the displacement is half of the amplitude. Potential energy EP equal to, we know, half m omega square x square. Okay, and it is given 2.5 joule, but the displacement of the particle, it is given, it is equal to a by 2, that is the half of the amplitude, and it is 2.5 joule. And question is asked, what is the total energy of the particle? Total energy, we can write half m omega square equal to 2.5 into 4, and the result is 10 joule. Correct option matches with 2. And move on to the next problem. Two tuning fork A and B produces notes of frequency 258 Hz and 262 Hz. Unknown note sounded. Unknown note, let us say the frequency of the unknown note is N, and it is 258 Hz. It is the tuning fork A, and another tuning fork, it is 262. This tuning fork is B. Bit frequency between these two, let us say X. Let's say the bit frequency is X, and bit frequency between these two, it is equal to 2x. Bit frequency between A and unknown note, it is actually X, So frequency of unknown note it is equal to 258 minus x. So therefore we can write 262 is the frequency of the tuning fork B, and the frequency of unknown note it is 258 minus 6. So 258 minus x, and the bit frequency is double. If the bit frequency between unknown note, that is frequency n, and the 258 is equal to x, then the bit frequency with n and b is equal to 262. So by simple equation we can equate this 262 minus 258 minus 6 is equal to 2x, and by calculation we can say the x is equal to 4, and the answer of this problem it is actually 258 minus 4. So this is 254 Hertz. And the right option here is 3. Let us move to the next problem. So question number 21, the temperature of a radiating body increases by 40%. You know, from Stefan's law, we can say energy radiated per unit time per unit surface area of the body is directly proportional to the T to the power 4. Here T is the absolute temperature. Absolute temperature of bodies. So the new energy because of the increase in temperature, it is E prime by E. Increase of the temperature is 40%, so the new temperature is 140 by 100, and it is 1.4 whole square, and by squaring this it is 3.84. So the percentage change in energy into 100 is equal to, it is 3.84 minus 1 into 100, and finally this becomes 284%. The right option, it is equal to, right option is 2. Next problem. Two masses of 8 kg and 6 kg are connected by a string as shown in figure over a frictionless pulley. The acceleration of the system. First of all, we have to check, the body is placed over a inclined plane. One body is placed over inclined plane, and other body connected by the string passing over the pulley hangs vertically, and the mass of this is 6 kg and mass of this is 8 kg. Here the gravitational component that will act mg sine 60 degree, and here the gravitational pull equal to mg2. It is obvious, m1g sine 60 is greater than m2g. So the body moves with a common acceleration because of external gravitational force on the body is m1g sine 60, which is greater than the m2g. So because of that, the two body moves with an common acceleration A. The body one which is placed on inclined plates moves down with an acceleration A, and the body here hangs vertically, moves up with an acceleration A. So common acceleration here A, we have to check, here tension T xi from body, here tension T xi from body, same string, same tension, and this tension is the internal forces for these two bodies, for the system of these two bodies. So internal forces has no contribution in the production of the acceleration of these two bodies. As per the Newton's second law, rate of change of momentum is directly proportional to the external force. So the acceleration of two body system, common acceleration of the two body system along the acceleration, the value of force is mg sine 60, and against the acceleration the external force is m2g. In this case, point to be remembered, when we finding out the acceleration, common acceleration of the two bodies connected by the string, along the direction of acceleration you have to take plus, or against the direction of acceleration the external force is m2g, that is minus m2g by total mass. And this becomes m1 sine 60 minus m2 by m1 plus m2 into g. m1 given in the problem, it is 8 kg. 8 into root 3 by 2 minus 6 kg by 8 plus 6 into g, and it is 4 root 3 minus 6 by 14 into 10. By default I have taken here the value of g is 10. It is 0.8 by 14 into 10, and this is 4 by 7, and roughly it is equal to 0.6 meter per second square. And the right option here is, right option here is 4. Next problem. Between the plates of a parallel plate condenser, there is 1 meter thick medium of sheet of dielectric constant 4. It is charged at 100 volt, the electric field volt per meter between the plates of the capacitor. Electric field E equal to, between the plate of capacitor, let us the charge is positive and negative charge, electric field is E, and the potential difference between these two plates is V. So in the electric field inside the capacitor equal to V by D, and the V, that is the potential difference given in the problem, it is 100 volt, and thickness of the condenser 1 mm, that is 10 to the power minus 3 meter, and 10 to the power 5 volt. Simple question based on the formula. Electric field, inside the condenser, that is through the dielectric medium. Whatever may be the dielectric medium, doesn't matter, since the potential difference between two plates of the condenser is given. and according to the simple formula of the definitions of electric field, you know the potential gradient of negative potential gradient is the electric field in a field, that is the electric field is equal to potential difference by separation, that is D, and by calculation it is 10 to the power 5 volt. And the right option here is 1. Next problem. 2 microfarad. So question number 24, it is again asked on the capacitance, capacitor and capacitance. Here the battery is removed and it is connected to a series combination to a uncharged capacitor shown in figure. Here one capacitor is charged. It is 2 microfarad and given 30 volt. This 2 capacitor is connected across the series combination of 2 capacitor. It is 3 microfarad and it is 6 microfarad. C1, it is C2. You know, equivalent of these two, equivalent of these condensers, it is actually, you know, 3 into 6 by 3 plus 6, 2 microfarad. So we can say that one condenser of 2 microfarad is connected across the other condenser of capacitance 2 microfarad, because the combination, the equivalent of these two capacitance 3 microfarad and 6 microfarad is equal to 2 microfarad, and it is the charge sharing taken place between these two condenser. One is charged condenser, another is uncharged condenser. From here we can get the common potential. You know, common potential equal to, due to the sharing of charge, equal to Vc equal to C1 V1 plus C2 V2 by C1 plus C2. Here this one I have taken is V2, that is the potential of this combination is 0 and potential of this combination is 30 volt. The capacitance of this is 2 and the potential is 30. Potential across the other condenser, that is the equivalent of 2 condenser, it is uncharged, so potential difference across this is 0. 2 into 30 by 2 plus 2, so 60 by 4, it is 15 volt. Potential across the combination, across the series combination, potential difference across the series combination, that is, we can write here potential difference of this combination is 15 volt across after sharing the charge. But here we have to find out the final potential difference across C1. Final potential difference across C1. Okay, so final potential difference across C1, you know, potential divides into two parts. In the case of condenser, potential divides in two parts in inverse ratio of the capacitances. So potential difference across condenser C1 Here in the combination C1, the value of C1 is 3 microfarad, so it is VC2 by C1 plus C2. Since the capacitance divides into parts in inverse ratio of the capacitances, so potential difference across the condenser C1 in the combination, we can write V1 is equal to VC2 by C1 plus C2. V, the value of V is 15 and the value of C2 is 6 by 3 plus 6, and it is 15 into 2 by 3, and finally the potential difference across this is 10 volt, and the right option here matches with 1. Next problem of this session, question number 25. Let us see what is the questions here. Charge of a body is always an integral multiple of. Simple question, you know, charge. Electron is a tiny particle having the amount of charge 1.6 10 to the power minus 19 coulomb, and all the charges reside over the any body or in the nucleus. Always it is equal to the multiple. It is integral multiple of the charge of an electron. Charge present on an electron. So right option here is 3. Simple questions. So simple questions, always you need to remember that the charge always remain on anywhere on any body, charge body, or inside the nucleus, always is the integral multiple of the charge of electron. Okay, next problem. Flux of magnetic field through an area bounded by closed conducting loop can be changed by changing. You know, magnetic flux equal to, we can write A dot B. A dot B is AB cos theta. Here A is the area and B is the magnetic field. B is the magnetic field and cos theta is the projection of A on B. That is theta equal to angle between B and normal unit vector to the surface. Normal unit vector to the surface. So flux of magnetic flux field through an area bounded by closed conducting loop can be changed by changing magnetic field. It is true statement. Area of the loop, it is also true statement. Angle between area vector and B, it is also true statement. So 1, 2, 3, all 1, 2, 3, all option from 1 to 3, all the option are correct, and true statement of this problem asked, but 1, 2, 3 are not the correct answer, correct option here. Answer is correct, but option is not correct because another option given it is all of the above. So right option you have to choose, it is 4. And next problem. The deflection in moving coil galvanometer is directly proportional. Moving coil galvanometer. A coil is placed in a magnetic field and it can be rotated. The coil is suspended by a spring because of when current is passing through this coil. Initially, let us say the coil is placed parallel to the magnetic field. And torque equal to B na sine 90. If we take the normal drawn on the surface of the coil, then normal is perpendicular to the magnetic field. So angle between normal vector to the surface with the magnetic field is 90. So torque simply it is equal to B na. B is the magnetic field strength, I is the current passing through the coil, N is the number of turns, and A is the area of the coil. And because of this torque, the coil, due to this torque, coil deflects by an angle theta. Let us say coil deflects by an angle theta. So what happened because of the deflection theta, the suspended wire, that is spring, will be twisted by an angle theta. Because of the twisting, the restoring couple restoring moment of couple due to twisting it is equal to C theta. And in equilibrium, C is the torque produced due to per unit twist. If C is the torque produced due to per unit twist because of its elastic nature, then the restoring torque is equal to, we can say, C theta. And in equilibrium, we can say, we can write B na equal to C theta. Let us check the option given here, directly proportional to the torsional constant, the deflection, that is theta. Directly proportional to the number of turns, inversely proportional to the area of the coil, and inversely proportional to the current flowing. Here theta is the deflection, it is equal to B na by C. Deflection theta is inversely proportional to the torsional constant. C is also known as, I must mention, C is also known as torsional constant. So theta is inversely proportional to torsional constant. So this is not the correct statement. Theta is directly proportional to number of turns. 2 is the true statement may be the right option here. Let us check the other option also. Inversely proportional to the area. This is not true. Theta is directly proportional to area. Inversely proportional to the current flowing. It is also not true because theta deflection is directly proportional to current. So the right option here is 2. 1, 3, 4 are not the correct statement of this problem. Next problem. A galvanometer of resistance 100 ohm is shunted so that 1/11th of the main current flows through the galvanometer resistance. So the shunt required, galvanometer we can write, let us say it is galvanometer, current passing through this is Ig, the maximum current that can be passed. It is the galvanometer. We have to add this galvanometer is shunted by the resistance S, and it is the circuit current I, current through shunt it is S. So we can say this galvanometer behaves like a ammeter of the range 0 to I ampere current, that is range is I, maximum current can be measured by this arrangement is I, but the galvanometer can tolerate the current, maximum current tolerate is Ig. Here the circuit current, the current that has to be measured or the range of the ammeter, it is actually greater than Ig. So shunt required S equal to, it is G by N minus 1. Here N I by Ig, N is the I by Ig, it is known as shunt factor. Is shunted so that only 1/11 of the main current flows through the galvanometer. So current that will pass through the galvanometer is I by 11. So shunt factor here is 11. Simple. The resistance of the galvanometer, it is given 100 and the value of N is equal to 11 minus 1, and the shunt required for this combination, for this problem, it is 10 ohm. And the right option here is 3. Next problem. The vertical component of Earth's magnetic field at a place is given 0.16 root 3 10 to the power minus 4 Tesla. What is the value of horizontal component of Earth's magnetic field if the angle of dip, that is, angle of dip, it is, if I say it is magnetic meridian, in a magnetic meridian, a needle is suspended freely. This angle, let us say, is theta, and the theta is known as true dip. If the BE is the geomagnetic field strength, that this means it has the two component, it is horizontal component and it is vertical component. This magnetic meridian actually geomagnetic meridian. If the needle is freely suspended in a geomagnetic meridian, then the angle subtended by the north pole with the horizontal component is the true dip of the place. And true dip tan theta can be written as V by H. Here vertical component is given. We have to find out the horizontal component of Earth magnetic field. So H equal to, we can write V by tan theta and the value of V given in the problem 1.6 into root 3 into 10 to the power minus 4 by tan theta. The dip is given is 30 degree, tan 30 is equal to 1 by root 3. Finally, the answer is 0.16 into 3 into 10 to the power minus 4 Tesla, and the correct option here is 3. Let us see the next problem of this video session. A vehicle travels half the distance with the speed v1 and other half with speed v2. That is, let us say the total path length of the journey is s and s, that is total path length is 2s. Half of this, the velocity of the car, half of the path is v1, and the next half of the path, the velocity is v2, moving with constant velocity v2 for this rest of the path, rest of the half of the total path. So this is, we can say, path average. Average velocity definitions, total displacement all time in Newton. Remember this, that definitions of average velocity is always, it is total displacement by total time. Total displacement by total time. So V average, it is actually S plus S by T1 plus T2, and S plus S, it is 2S. T1 is equal to path length by V1, and this is path length by V2. It is the path length S, and finally the answer becomes 2 V1 V2 by V1 plus V2. The formula can be rearranged for your better understanding or to easy memorizing. For easy memorizing, the formula can be written as 2 by V average equal to 1 by V1 plus 1 by V2. For the two equal half of path, the formula becomes the result becomes 2 by V average velocity equal to 1 by V1 plus 1 by V2. And for n equal half, generally talking, for n equal equal parts of path, let us say the velocity is v1, v2, v3, vn. So we can write it is for n equal part, v by n by v average equal to 1 by v1 plus 1 by v2 plus 1 by v3 and ... it is 1 by vn. All time for this type of problem, you just remember it. If the car moving with the velocity v1, v2, v3, vn for n equal parts of path, and this is known as path average, and in this case it is n by v mean equal to 1 by v1 plus 1 by v2 plus 1 by v3 ... 1 by v1, 1 by vn. And here the right option is 2. Next problem of this session. Liquid have no Poisson's ratio because theoretically If you go through your basic test, you know the liquid or gas have no particular shape. It will take the shape of the container in which the liquid or gas is liquid and gas is it will take the shape of the container in which the liquid and gas is placed. Okay, so they have no definite shape. This is why there is no Poisson's ratio. As you know, Poisson's ratio is the lateral strain by longitudinal strain. There is no question arise of length and breadth of a breadth of liquid or gas. You know, it has no particular shape, so the right option here is 1. Okay, next, a person can see clearly only up to a distance of 25 centimeters. A person can see clearly only up to a distance 25 centimeters. He wants to read a book at a distance 50 centimeters. So definitely this person has some defect in eye, and the persons cannot see any object above the distance greater than the distance of 25 centimeters. If the distance is greater than 25 centimeters, this person cannot see. So the person has the problem, it is short-sightedness. It can see the object closer to him. If the object is at the distance 25 centimeters, then he can see the object clearly. But when object distance is greater than the 25 centimeters, he cannot see. So this is, you know, the problem based on the short-sightedness. Okay. Here, you know, lens equation 1 by V, 1 by U, 1 by F. This person wants to read a book. This person wants to read a book that placed at 50 centimeters. So quite obvious that object has to be placed at a distance minus 50 centimeters. Okay, it is the human eye and the lens is placed. Let us say lens is placed and object have to be placed. So object distance is minus 50 centimeters, but this person can see the object at 25 centimeters clearly. Whatever may be by the help of the lens, the lens can support or helps the person to see the object, but defect of the eye cannot be removed by using the lens. Lens can just support or helps the eye to see the object. Here V, that is, he can see the object clearly at 25 centimeters. So the image formation by the lens used in this eye should be at minus 25 centimeters. And if we put here 1 by F, it is equal to minus 1 by 50 and it is equal to 25. Okay. And it is 50 minus 1, sorry, one by F, it is minus 25 plus 1 by 50 and the value of A is equal to minus 50 centimeter power equal to 100 by minus 50 equal to minus 2d, and the nature, it is power, and the nature of this is diverging. The lens is diverging, or diverging actually it is, if we take the shape of the lens, it is actually concave. The nature of a concave lens in here is diverging. So according to problem, the right option here is power is minus 2 and shape is concave. 3 is the right option here. And this problem also can be solved by some technical approach. Other way, you know, object is real, any object anywhere placed when it is observing by any person, or when it is placed at the principal axis of lens or mirror, whatever may be the nature of object is always real. And image formed by the lens in the case of spectacles, always it is virtual, and if the problem is short-sightedness, the lens you have to use, it is the nature of object, it is the nature of image, and D is the nature of lens required. D, diverging, is used for short-sightedness. D for diverging. And the RVD equation always you can write, it is equal to 1 by U minus 1 by V. Okay, sorry, RVD equation is equal to 1 by F is equal to 1 by F is equal to 1 by V minus 1 by U. This equation actually, there are 3 type of codes you can get in the ray optics. It is first code is one RRC. RRC matlab the object, first R is the object nature, second R is the image nature, C is the nature of lens of mirror, that is code is RRC, and the equation used for this code is 1 by V plus 1 by U is equal to 1 by F. Another code, it is RVC. R stands for object nature, V stands for image nature, and C stands for nature of lens and mirror, that is code is RVC. And for this code the equation is always used is 1 by F equal to 1 by U minus 1 by V, after putting the sign as per the sign convention. And the last code RVD, R is the real object, V is the virtual image, and D is the diverging lens or mirror. For this code, the equation always used is equal to 1 by F equal to 1 by V minus 1 by U. 1 by V, it is 25 centimeter and it is 50 centimeter, and by calculating it is 50 centimeter. Here there is no sign is required. In the traditional way, the focal length already we have found here it is minus, but in the coding system there is no sign will be required. There no sign is required. You just put the value and find the magnitude of the focal length, but nature you already understand it is diverging. If the nature is diverging, then the power is negative. If the nature is diverging, then the power of lens is negative. If the nature is converging, the power of lens is positive. So simple power is equal to 100 by 50, and it is 2 diopter. and the right option here again is equal to right option here again it is 3, that is concave. Concave means the shape of the lens which having nature is diverging, and the power is -2 diopter. Next. Okay, question number 33 says in a common emitter mode of transistor, collector current is 5.488 milliampere for an emitter current of 5.60 milliampere. We have to find out here the current amplification factor. You know, in CE mode, current amplification factor beta, it is output current by input current. Here we know output current in CE mode of CE mode of the connection. The output current here the collector current, and the input current is the base current. Okay, here in this problem in the CE mode, you know, the current provided by emitter, that is supplied by emitter, as per the Kirchhoff law, we can write it is IB, that is base current, plus IC, it is collector current. So IB can be written, it is IE minus IC. The value of I given in this problem, it is equal to 5.60 minus 5.488, and this value is 0.112 milliampere. Putting the value of the collector current, that is output current of the transistor, it is 5.488 by 0.112, and roughly this calculation, this becomes 49. So the current amplification factor will be 49, and right option here is 2. Next problem of this session, question number 34. In a lens of refractive index n is put in a liquid of refractive index n prime, focal length of the lens is here is f, and its focal length in liquid will be. Here this problem is based on the lens maker equation. The focal length of the lens given in the air is f. We have to find out the focal length of the lens when it is immersed in a liquid of refractive index n prime. Okay, and you know lens maker's equation, lens maker equation 1 by f equal to n minus 1 by r1 by 1 by r2. Here n is the refractive index of lens with respect to air. Okay, when this lens is immersed in the liquid, 1 by f prime is equal to, you have to write in this case, n is the refractive index of lens by n prime, that is with respect to liquid. So we have to find out the refractive index of lens with respect to liquid. So n by n prime minus 1, and it is 1 by r1 minus 1 by r2. If we divide these two equations, it would be f prime by f, it is n minus 1 into n prime by n minus n prime. Okay, so focal length, new focal length f prime, it is f n minus 1 n prime by n minus n prime. Here, if we go through the 4 options given here, you know, so this is not the right option, this is also not the right option, and option 3 is also not the right option. Minus given As per the problem, there is no indication given that the refractive index of liquid is greater than the refractive index of lens, or refractive index of lens is greater than the refractive index of liquid. So no such indication is given in this problem, but I think as per the option given minus, so problem in this problem, actually refractive index of the liquid is greater than the refractive index of the lens. So this is why the value of the focal length, that is nature of the focal length, changes and it becomes minus. But no such indication it is given, but as per the option given in this problem, so no way you have to find other any option. So option 1 is here is the correct option. Next problem. An electron of a stationary hydrogen atoms jumps from 5th energy level to ground level. You know, 1 by lambda equal to r minus 1 n square minus 1 by n2 square. Wavelength, that is the wavelength of the photon emitting out of the atom because of the transition of electron from higher state to lower state, and the wavelength is equal to 1 by lambda, that is r into 1 minus n1 square by minus 1 by n2 square, that is wavelength, and r is the readback constant. So here r, it is given in the problem, it is ground state, and it is given it is the from the 5th orbit. So transition of the electron taken place from 5th orbit to ground state. Okay, and it is 24 r by 25. So momentum of photon, you know, de Broglie, as per de Broglie, we can get the momentum of photon P equal to h by lambda, and 1 by lambda, it is already calculated, it is 24 r h by 25. But here we have to find out the velocity of that atom acquired by the result of photon emission. Because of the photon emission, the momentum of the photon, as per the de Broglie hypothesis, it is 24 r h by 25. And from, if we say it is atom, here a photon emission taken place with the momentum p. As per the conservation of momentum, the momentum of atom, let us say it is A, momentum of atom is PA. So according to conservation of momentum, the momentum of atom will be equal to the momentum of photon, because before emission the momentum of the total system is 0. So this is why the two momentum of photon and momentum of nucleus will be equal and opposite, equal in magnitude and opposite in direction. So momentum of atom is equal to, we can say, h by lambda. Not necessary to write h by lambda. It is, let us say it is 24 r h by 25. And velocity, we have to find out the velocity of the atom after emission of, due to the emission of photon. It is m into v, let us say the momentum, and v is the velocity of the atom. It is 24 r h 25, and the velocity would be 24 r h by 25 into m. And the right option here is 1. Let us see the next problem of this video session. This is last questions of the section A, and I will be dealing with the section B for the next video session very soon.